There we go. All right, guys. So welcome again. We are back at the CCNA initiative. We are on chapter 5, right? Where, we're discussing, switching concepts and basics or what have you, right? Remember the key things I told you guys, right? The three main functions of a switch, right? Number one, deciding when to forward a frame or when to filter, meaning to not forward a frame based on the destination MAC address. Okay. Preparing to forward frames by learning MAC addresses by examining the source MAC address of each frame received by the switch. Okay. That's two. Last but not least, right? And we're going to get to this in the future because this is actually my fun part and it's a precursor for routing is preparing to forward only one copy of the frame to the destination by creating a layer 2 loop-free environment with other switches by using spanning tree protocol. Okay. But in this slide, we're going to examine just the first two main functions. Okay. Because it's going to prepare you for that third major function. All right. So let's go ahead. So remember that topology, of course, with Fred, Barney, Wilma, and Betty, right? So we have that in here, what have you, right? What I'm going to do in this lab, right? We're going to look, we're going to go examine how those two functions work, right? We have a switch, right? Switch one, right? I'm actually in it now, right? And to take a look at that MAC address table, right? Because that's what mitigates where to forward and where to filter these frames that are sent, right? From these hosts. It is mitigated through that MAC address table. So let's take a look at the MAC address table, right? And of course, like I told you guys, I love the question mark, right? Because it tells me, some commands that maybe I don't know. So let's look for anything that has to deal with MAC, okay? All right, so see MAC right here, right? Show MAC configuration. So let's take a look at that, right? So show MAC, okay? Question mark, all right? And we're looking for the MAC address table, okay? So MAC forwarding table, that's another term for it, right? So, but essentially it's the MAC address table, all right? You do enter. So there's nothing there yet because we have not turned any PCs on. And these PCs don't have any IP addresses yet. So I'm going to set these up in real time, right? I'm going to assign names to them. And we're going to take a look at their MAC addresses, okay? So let's go ahead and pop that up. While I'm doing that, let's organize everything. Boom. There we go. 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 Betty. And then we got Barney. There we go. All right, so we have them there. All right, and let's go ahead and hop into the PC. Okay, slid over there. Let me go ahead. All right, let's do a show. Okay, so there's nothing yet. All right, so there's the MAC address, right? Okay, and we'll come back and take a look at it. But for communication to happen, of course, between these different devices, we need to make sure that we assign an IP address. So I'm going to go ahead and do that now, right? So make it simple. 50. There we go. And no gateway, right? We're good. And I'll explain why I'm not going to send a gateway on purpose. I could have, but again, I don't want to complicate things. So we have dot 50, and as I tend to forget things, let's go ahead and, okay, there we go. All right. 50, cool. Go. And let's give 53 to Betty and 54 to Barney. There we go. Okay. All right. Well, let's make it a little bit more prettier. There we go, right there. Let's move right there. Excellent. Give it some room. All right. So we have that. That's good to go. All right. Let's go ahead and assign Wilma. Same thing. Boom. All right. Assign her IP address. 51. There we go. All right. And let's do Betty. And then we're going to come back and get all their MAC addresses because we're going to do a compare contrast. Okay. So let's do an IP. We are on Betty on 2063.1.53. And she's in the /24. Okay. And we'll talk about cited notations in the future. Okay. And let's go ahead and assign an IP to Barney. Here we go. All right, I want to get to the IP. I want to get to 168.1.50. Oops. 4. Okay. There we go. All right. So let's go ahead and we're going to pop some packet captures, right? And our source for this lab is going to be Fred, right? So .50. So I'm going to capture on Wilma, Betty, and Barney. Okay. So we're going to have packet captures going on in the other screen. Okay. And these packet captures are done via Wireshark. We could have done TCP dump. We'll get to that in the future. That'll be like a, extra credit fun thing to learn about TCP dumps and how to do it in Linux. But, that's beyond the scope of the CCNA. But it's a good thing to, fun thing to learn what it is, because essentially that's all that Wireshark is. It's just done in GUI form. Okay, nothing yet. Let's pop it again, because sometimes even G is wonky. Let's go ahead. There we go. And I bet you now we should see some things. There we go. All right. All right. Okay. Free connect. All right. Let's do it again. Come on, Eve. What's going on? 2. There we go. There we go. Okay. All right. So we got the port. It's connected to Wilma capturing. And what port is this? 0.3. Okay. Let's capture that. There we go. Okay. See those layer 2 packets. All right. And let's see. Oops. Let's capture on Barney. There we go. Okay. There we go. All right. So let's go back to the switch. Okay. And let's go ahead and take a look at the MAC address table. All right. So that command, show MAC address table. All right. All right. So, right, we see the MAC address table, it's populated, right? I'll tell you the reason for that in a second, because of course we haven't sent no traffic. So we'll talk about that soon. But we see some MAC addresses, right? And I am actually going to clear the MAC address table, okay? Yeah. Now, if I take a look at it, shouldn't be anything in there. Okay, awesome. So our lab is reset. Let's go ahead and reset the terminal just in case. Show them that address table. There we go. Okay. All right. So our goal, right? We want to go ahead and, go ahead and prove these first two main functions, right? Of course, deciding where to forward a frame and where to filter, and how to learn MAC addresses based off the source address. Okay. So let's go ahead and we are going to log on to Fred's PC. And what we're going to do, okay, let's reset this terminal too. There we go. All right. And we are going to try to ping Barney. And let's see if that works. Okay. 102.168.1.54, which it should work theoretically. All right. So pings are rolling, right? Pings are rolling. They pass. Perfect. Right. So what we should expect, right? We should see MAC addresses for mostly all the PCs, right? Mainly Fred and Barney, right? Because these are the two hosts that are communicating with each other. Okay. So let's take a look at the MAC address table now. Okay, perfect. All right, so we see that, right? And let's break this down a little bit, right? So we're not going to look at the config on each PC. We're just going to go ahead, and this is where you'll start to learn the reverse engineering and troubleshooting and what have you. If we look at the switch, right? This show command tells us a few things, right? These MAC addresses, right? Without verifying them, the switch is telling us, all right, it learned about these MAC addresses dynamically. Perfect, exactly what it's supposed to do, right? There was no configuration on the ports that they're configured to, so they're in the default VLAN, they're in VLAN 1, right? And they're hanging off certain ports, right? One is hanging off gigabit 0/0, one is hanging off of a 0/1, right? And we have the pleasure of looking at our topology, right? And sometimes that's not the case in the real world. But within our topology, we can go ahead and put two and two together, right? The MAC address for PC2 is this right here. The MAC address for PC4 is right here, right? Because again, it's deciding when to forward a frame or when to filter, not forward a frame based on the destination MAC address, right? And preparing to forward frames by learning MAC addresses by examining the source MAC address of each frame received by the switch. So let's talk about that. Fred sent the first packet, right? Trying to ping .54, which is Barney, right? So he sent it to the switch. So the switch said, oh, I know who Fred is, right? I know where he lives off of. He lives off of gigabit 0/0, right? And this is his MAC address. Boom. That second main function is learned, right? It did its job. Boom. It learned about Fred's PC, right? Fred's MAC address, right? And so, but it hasn't fulfilled the first main function yet, which is deciding where to forward it, right? And so in the background, right, if a host doesn't know where something is, right, doesn't know where another host is on a network or a broadcast domain, to be technical, it is going to send a broadcast message, okay? And so what that switch is going to do, and we'll get to that in the future, what that switch is going to do with that broadcast message, it is going to go ahead and forward it out of all ports that it learned it off of, except for the port that it received that frame, right? In simple terms, it's going to shoot that frame out of every port except for the port where Fred lives off of. Okay, so what's the purpose of that, right? So the purpose of that is the switch is trying to yell and scream and say, "Hey, who's who's this, right? Who's Barney, basically, right? To keep it simple, who's Barney?" And whoever responds will go ahead and just respond with the response frame, right? Because again, we're gonna still call this a frame and not a packet because we are at layer 2. Okay. So if somebody responds, right, they're going to go ahead and send a response, right? So those pings, those ICMP responses, they're going to go ahead and get a ICMP reply, right? And that reply is going to come from Barney. So Barney's going to go ahead and send that reply, right, back to Fred and say, hey, Fred, I'm here. What's up? What you need, right? And you're going to send it to switch one, right? Send it to the switch to get to Fred. But then what is the switch going to do? The switch is, because now the roles are reversed. The source and the destination of that, that layer two frame to where it says source and destination. Now the roles are reversed. The source is Barney and that destination is Fred. So now what the switch is going to do is say, I know where the destination is at. So now we're going to fulfill that first main function of the switch. And again, I repeat, it's deciding when to forward a frame or when to filter, not forward a frame based on the destination MAC address. The destination is Fred now. So now it's going to go ahead and the switch says, hey, I know where to send it, right? And so now the switch knows about Barney and Fred. So back and forth, it's back and forth, the switch now, right? Between these pings going between each other, between Fred and Barney, it's going to go ahead and automatically know where to send it, right? And it's going to fulfill main function one, main function two, main function one, main function two, all throughout the same time. Okay, right? And it's also not going to send any frames outside of gigabit 0/2 or 0/3. Because again, going back to that second part of that first main function, right? The switch has to know when to filter, when to not forward a frame. It's not going to forward those frames out of gigabit 0/2 or 0/3. Why? Right? I can't tell you guys, oh, it's just not going to do it. That's not going to work. Right? You guys are going to be like, Dave, that's not enough. It's not going to forward it. Why? Because when that first broadcast message was sent out, Wilma and Betty did not respond. Those hosts, .51 and .53, did not respond because they were not .54 in that 192.168.1.0/24 network, right? Okay, so they didn't respond. They may have received the broadcast message, they did not respond. So what does that mean? Going back to that main function of that main function number two, right? The switch can only learn about MAC addresses by examining the source MAC address. If the roles never reverse like it did for Barney, right? The switch will never know about Wilma or Ben. Okay, so that is exactly how that works. Okay, it's exactly how switching works and how those main functions works. We'll talk about that third function in the future. We talk about spanning tree, which is a different beast. I just wanted to show you guys how this works, how this looks, right? And and how the basics of switching works. Okay, so last but not least, I want to drill this in your head, right? Remember that that screenshot that I sent you. Matter of fact, I can actually pull up the PowerPoint, right? I just want to make a quick note and say this last thing before we get off, right? A switch's MAC address table is also called the switching table or bridging table or the CAN table, and referenced for the type of physical memory used to store the table. You guys are gonna have to learn, right? And we spoke about it in chapter 4. You guys are gonna have to learn, remember about these things, these little notes and tidbits about a Cisco switch if you decide to take the CCNA exam, because you're going to be tested on where, where MAC address table, where that memory is stored, et cetera, in these specific terminology, right? And moving forward, you're probably going to hear me say a lot of terminology is going to spew it at you, but after a while, right, I'm going to keep saying it and saying it and saying it to where you guys, it's going to be second nature, okay? Well, that's it for today. We don't have to go in depth. I think you guys got the basics, right? I'll go ahead and upload this to YouTube. Hopefully you guys can take a look back at it and try it in your own lab on Packet Tracer. And you guys have a great day.